Hey, how are you all doing today? Welcome to the Embedded Hour, and we got quite an interesting session this week. My friend Whitney is going to be joining us, and we're going to be having a chat about all things RF and FPGA related. And I'm sure we'll stick to topic and we'll not go wandering off at all. A few things first. I wanted to just run through and cover through. So hopefully you can all see my screen, and we'll take a run through it. So I guess, just like always, just like any of the other, thank you for coming back and rejoining us, and welcome to anybody that's new and the first time they've started it. If we want to really feel like a community and a discussion, so please feel free to talk, interact, ask questions, put comments in the chat window and such like. We'll read them out and we'll have a chat and we'll see where we're going. Obviously, we really don't mind. We work with professionals all the way through to enthusiasts. Everybody's welcome here. I've hit the record button, so what we're going to do is we're going to record this, and then we will make it available on my YouTube channel afterwards. And we've got a simple-ish post-event survey. So if you could take a few minutes to fill that in, I'd really appreciate it, and we'll take it from there. So I don't really have too much to say before we jump in. And we talked with Whitney. One of the things I did want to show though, and I was really hoping that I could have one of these in my hand today. Unfortunately, they're still stuck at customs because there was a little delay in customs release. But last month when we talked about this, I was showing this little Ultra 96 breakout board that I've been designing that had some PMOD breakout on there and had some Zmods, Zynq type breakout. So this month I've got them. We've actually got them back. We've got them in. My good friend Dan Binnens actually received one because he was in the US. So he's done the all important things actually that worried me. So he's done the mating of the two boards between the Ultra 96 and the little mezzanine card, because I was a little worried that between the high speed connector and the low speed connector the two might not mate. But it's all good and it's all mated and it all powers up. So we're going to be I'm going to be actually sending a few. So I've got a few of these. So I'm going to be sending them around to people. So I'm going to send one across to Whitney and a couple of other people in the USA. But if you've got an Ultra 96 and you've got an interesting application or idea for it, then drop me an email. You should all know my email, but it's adam@nuvioengineering.com. Drop me an email and I'll try and provided they all work. I've still got to prove out all the signal integrity and everything. But provided they work, I'll send you some. I'll send some about, and we can try and make some interesting projects with them. I've also been doing a few other interesting things. I don't know, so I was trying to capture NeoWise, the comet with my little FPGA based imager, and I wrote all that up on Hackster recently, which I thought was quite an interesting project. Unfortunately, due to the weather, I never actually got to actually capture an image of the comet, but managed to take some good pictures along the way, and the all important thing really was to have some fun. And you may or may not have noticed, actually, most likely not, but I've actually launched a new website, and that's going forwards. Actually, that's where all my blogs are going to be hosted. The projects are still going to be popping out on Hackster, but the blogs are going to be all located on my website, and that's because I've got some ideas about different things I want to do and control and such like. But there's one thing I wanted to ask, which is a little bit of a kickoff start to the question, and we'll talk about it. In fact, it's one of the questions I'm going to be asking Whitney in a little while. And I was thinking a little bit in the last couple of weeks. I've been doing an FPGA architecting some FPGAs, and I'm really curious as to how you do your architecture, how you sit down with a blank idea and create the FPGA design. So any comments you've got, please feel free to stick them in the chat window here about how you do it, or reply back to the blog. But I'm really quite curious about that, because it's something I think is everybody kind of takes for granted. I always go with the sketch on a piece of paper and then Visio or something like that. But I'm really quite curious as to how everybody does it. I've got a little bit of an idea for a product behind it, which is why I'm asking the question. So that's pretty much all I've got to say about what I've been up to, and we're not here to really talk about what I've been up to. We really want to talk with Whitney. And Whitney's the founder of a company called Knitronics, which is a really interesting symbol. And she's one of the few people that understands not only FPGAs but also the RF world and the outside world as well. So, can you hear us, Whitney?
Yes, I can. Can you hear me?
We can. Yes. So welcome to the Embedded Hour. And
thank you. I'm very excited to be here and honored.
not as excited as we are to have you. So maybe, I mean, I gave you a little bit of an introduction. So if you're not familiar with Whitney, she does a lot of content creation. She's been doing some really great blogs and some great projects on Hackster and on her own website, Knitronics. I think we first met. We were just talking about this when we were practicing before the session, and we're really organised that we left it to the hour before we actually started having practice. So we're professionals at managing time.
True engineering. You engineer it in the moment.
Exactly, true engineering. we realised we kind of met through one of the embedded systems conferences.
Yeah, I'm trying to remember. It's been a few years ago. It was in Boston. I think that might have been 2017 or 2018.
Yeah, it must have been. I know there wasn't one this year, so I've been to the previous one, so it must have been sort of 2017 or 2018. But so, do you want to give us a brief introduction to what you are and what you're doing? Because I think you can say it a lot better than I can in terms of because you've got some really great projects. You've worked with everything from the RF to the Zynq break. So
I started off. I guess I'm from the U.S. specifically. I in Kansas City, where I went to school I got undergrad and master's degree in electrical engineering, and I actually focused on my master's degree was in computational electromagnetics, and specifically to optimize to get some of the looking at infinite series to get it down to where you could deploy it on something as small as an embedded device versus needing a supercomputer. So that's kind of where I got my initial interest in where RF and embedded systems met. And then I went to my first real world job and promptly never really did the math behind my computational electromagnetics again, as I feel like it's pretty normal. Your master's thesis seems all encompassing, and then you get out in the real world and not quite didn't quite use that exactly, but I remember one of the first, I worked at a very large engineering firm as one of my first jobs, and there were just, when you're a new engineer at a large firm, all the little projects that the more experienced engineers that are running the bigger projects, they don't have time for, you just kind of get thrown those kind of things. And that was how I got into Xilinx FPGAs specifically, is there were a bunch of these little projects that nobody had time to do, and so they just kind of got thrown to me. And all of a sudden I had never even heard of Xilinx before. I'd always used some of the I've been writing in assembly and using, I think we used LabVIEW in my last Logic with the digital bias board. We used LabVIEW to program it, and we're writing pure assembly code. And I don't even remember how we got the assembly code on the bias board. I think they might have automated it for the lab so that we didn't really have to think about it as students, because they really they were wanting to teach us how to write assembly. They didn't care about us learning how to use the boards. But so all of a sudden I just got thrown these projects and was like, figure out Vivado.
It's fairly simple. It's nothing but a few thousand hours and a lot of lost sleep on it.
And that's honestly the best way, because I feel like engineering school just teaches you how to teach yourself, really.
Yeah, I mean, I agree. I think that's a great point. Engineering school's the beginning.
Yeah, so I started just kind of working my way through Vivado, and that's actually, I found that there just weren't enough hours in the day to accomplish all of my work tasks, and then also figure out how to do some of the stuff from scratch, but it was interesting and I really enjoyed it, which is what led to me of okay, if I'm going to get this project done on time, and I also just want to know it for the sake of me knowing it, I'm going to have to start maybe kind of working on some of this on my off time. So I picked up some cheap dev boards, and this was right after Vivado. You could run synthesis for some of the lower grade FPGA chips without a license. And I started working on it at home, and I started figuring, and as I would come up to obstacles, if I couldn't figure out how to do it at work, or I couldn't figure out a time, I'd go home, focus on that one little thing. And then I actually started the little blog, and it was all private to myself as like oh, I'm not going to remember how to do this by the time I sleep on it and go to work in the morning. So let me just write it in the blog, like step by step, and then I can I can just pull my website up at work and do it. And that's how originally it was called Larson Nerd Lab at the time when I first started it.
I love that. We were talking about that earlier on. I was on your website, and I mean, if you want to share your screen and show your website, you know, I'm sure people would love to see it. But I was scrolling down your website. I think it was this afternoon as I was thinking about what can we talk about, and I saw it at the bottom. It's like formerly known as Larson Nerd Lab. So I was like, oh, that's brilliant.
So this is the website. It looks much it's much more well organized at this point. Yeah, when I first started this was just bare bones, absolute, because it was just for me. Like I think it could have been accessed by anybody, but I didn't share the link, and unless you were in a weird Google black hole and somehow found me. But so I actually had to put this little disclaimer here, because when I got married and I changed my name, my last name is now Knitter, and I don't remember how, but somehow the term, Knitronics, mixing the word knitter with electronics, and I just thought that was really cool, and I was like, oh, I want to change everything because it's a short little like cool word and it's unique to me. And when I went to change my Facebook page, Facebook got mad at me and said, you're misleading your followers because you're not talking about electronics anymore. You're talking about knitting. I was like, no. And I escalated it to the point that I actually had a live person talking to me from Facebook. And they're like, well, can you point us to a website that proves Larson Nerd Lab is now Knitronics? So I just pulled up Squarespace at the last minute and typed this little phrase. And they're like, oh, okay, now you can change the name of your Facebook page. And I had all of like 20 followers on my Facebook page. So I don't know why they were so upset about it, but
it's amazing sometimes the algorithms that you trigger and the things that it starts running through. So you started doing this, and actually it's quite interesting because you saying when we were chatting earlier on that you started writing these things down just because you couldn't remember to help you as an engineer. And actually that's really similar to how I ended up doing it. It's just sort of writing things down because I could find where it was, and well, couldn't perhaps remember what I was doing, but I could remember I wrote a project or a blog on it 6 months ago.
Well, and I couldn't remember A, how I did it, and then B, I felt like a lot of the times when you Google how to, obviously the second you get stuck on something, the first thing you do is Google it. And I remember I would find forums and you kind of piece things together and problem solve from there. And then when you would find tutorial things, like I remember one of my first tutorials that I found that I followed was on the Zynq Berry. It was posted on, I think, DigiKey's forum.
Okay.
And it was a good tutorial. It's just that sometimes when a more experienced engineer is writing some of these tutorials, they leave out some of the, like what they think is a really simple, obvious step. And it's like some little button you have to press or some switch flip. But as a new person, when you really need that blog, like it's absolutely infuriating that you can't figure out why this thing that should be simple isn't working. And then when you finally like spend hours and find that stupid little switch to flip, you're like, oh my God, why wasn't this would have been one sentence in the tutorial. Why was this? And so that's one of the things I'm very adamant about in a lot of my blog posts. And honestly, a lot of my blog posts, it takes me longer to write them than it does to do the project because I'm trying to make sure that I'm putting all those little gotcha steps in there that seem trivial and that I might forget it. Now that I'm experienced enough, I might forget to, like, it seems obvious to me, but I always want to make sure I leave those because that's the whole point is I'm thinking about past me when I'm writing these blogs. And it's like, I want to help those same engineers that are kind of in my position where they might be new at a job and they're kind of under pressure and they need to get this figured out. So that's kind of been my whole mission with it once I turned it public.
It's really good. I always kind of read everything that you put out. So we do it's really quite interesting. One of the things I wanted to ask you about actually and chat about was So the Zynq brake, you're quite a big fan of the Zynq brake, aren't you? You use it quite a lot.
I did because you had the MicroZ Chronicles, and I don't know why I got so attached to it, because I really like the Zynq from the sense of a lot of FPGA dev boards are fairly large and cumbersome, and like the first ones I worked with were like the KCU 105, which is just
it's huge, isn't it?
Massive. Yeah. It's like 1.5 feet square, and it needs a giant wall plug outlet, and forget about that thing being portable in any means, and or affordable as like a poor college kid or like somebody fresh out of college that you're trying to pay back your student loans initially. And I really like the Zynq because it was in my price range. It was still a splurge, but it was in my price range at the time. It's the same form factor as a Raspberry Pi, so that lent itself to, as I was pushing my boundaries and for like learning more about like FPGA design, I had all these Raspberry Pi accessories that fit it perfectly, and I didn't have to do any modifications. And then it's fully powered from its JTAG USB port. So I think that's where I got really attached to it, and I could, especially now that I live here in New York, I can just throw it in a little ESD bag with a single USB cable and then go sit in a coffee shop and develop. And I think that's just where I'm really attached to it at this point, and I know it well. And it was one of my first engineering challenges when I was trying to get the Ethernet port working. So I think, and I started the dedicated blog series to it, the Zynq patch that I have here, and I started like I think 2018.2. This is like right when 2018.2 came out. But I was trying to even remember how much, like, I think it was just purely getting the board set up and installing board files. And I think this only lives on this, because a couple of these very first blogs they solely live on Knitronics.com, and it was these couple first blogs on the Zynq that actually led to somebody at Hackster reaching out to me and asking me to write for them. But honestly, I know the Zynq seems like a really tiny board, but I've used it several times in an industrial setting to prove in a design, because they're cheap, they're easy to set up, and you really don't, most of the time you don't need much more than like an Ethernet port and some USB and some GPIO. So I've become quite attached.
I can tell. But I like your point about sort of you can just throw it in your bag and just sort of take it around with you. I did have a Zynq, but I actually loaned it to a friend of mine. So I'll never see that again. But I've got a similar. I have the Cora Z7. Is generally, because it's a really small type board, he's always generally sat in the side of my rucksack no matter where I am, because I figure if you've got a little dev board and a USB cable, you can at least have some fun. Well, if you're an engineer, that might be fun. It might not be. Other normal people might have got a different definition of what fun is. But so you've done this kind of the basics of the setting up it. But you've also been doing some really interesting work with CircuitPython. Do you want to talk about that a little?
Yeah. So I'll just pull that, or the initial. So because the whole quest of this, and one of the initial appeals of the Zynq was to utilize my Raspberry Pi peripherals. A lot of my Raspberry Pi peripherals are from Adafruit. And for maybe those of you that aren't familiar with CircuitPython is something Adafruit developed to make integration of their shields, like the Raspberry Pi shields, easier for users and to get started. And when I first started looking through everything, I noticed that a lot of the CircuitPython libraries had some very limited integration for the Pink board that's also Zynq based. So I was able to take some of that as a starting point, and then because the Zynq 40-pin GPIO exactly matches that of the Zynq, I was able to take the two and kind of cobble some things together and create an extra create an offset of the CircuitPython library with the pinout and drivers for the Zynq very specifically. In this picture here, where I started off with just something very simple, just a little OLED board. And I'll never forget, I spent like that initial, getting that library like together and getting the I2C and the SPI enabled, and then manipulating the Python in the CircuitPython library. That was one of those projects that when I started off, I was like, I don't think I'm ever going to get this to work. I'm just curious. And then after much trial and error, I finally did. And I remember when I finally got this Hello Zynq Fairy to show up for the first time, I was so excited. And my husband looked over my shoulder and he's like, you're going to make it do more than that, right?
So that's the great thing about engineering is, I honestly, I say it's very similar. You know, you sit in your office and you kind of work away, and then finally something works, and I'm like hooting for joy and shouting and screaming, and I'm really happy, you know. And my wife's like, so it works then? It's
like literally all it's doing is blinking at like a 1 second rate, this Hello Zynq Fairy, and he usually says like, it's gonna do more than that, right? Or will it do more? And just like very, just completely unimpressed. And like I'm like over the moon, just super excited.
So Dan's just put a really good comment in the chat, actually, saying that it sounds like your husband sounds like a manager.
yes. But,
yeah, and it's an interesting point, because a few more people have put something in there, you know, and it is really quite interesting, because Pat's just put in there a comment, you know, saying like, you know, you mean you've been working all this time just to see a signal on an oscilloscope or something? And I think, you know, perhaps not everybody really understands how much, I want to say, you know, blood, sweat, tears, hope, chicken sacrifices, praying goes into just, you know, sometimes it's that plowing through, just trying to get things working is really, people overlook it quite easily and go, oh, so that's it.
And this, honestly, I started with the OLED because my actual, the Raspberry Pi peripheral that I started off with that I really wanted to get working, because I have an interest in radios and RF, was I really wanted this Featherwing to work, the RFM69 radio Featherwing to work. And this kind of segues into something else I wanted to mention of when you first start taking on some of these projects and there's so much to unpack and there's so many of these new unknown elements, sometimes you really do have to pick a starting point and peel back and just start with that one easy, or like not easy, but the most simple building block, get that working, understand what made that work, and be like, and just not having the clutter around it. So you know you're only troubleshooting the one thing versus like, oh, am I troubleshooting this thing, or is there some other unknown thing that it's causing a chain reaction of things not to work? And so when I looked at this Featherwing, it's got the same OLED. I think it's like the 1306 or something like that. I can't remember exactly off the top of my head, but it had this OLED on it. And I was like, oh, I have a breakout of just this OLED. And that's what led me to start with just that. And honestly, being able to just focus on the OLED and just because the OLED only works on I2C. So just focusing on the I2C and doing that initial pinout design in CircuitPython for the Zynq Fairy, that was tremendously helpful, rather than starting off with both needing to do the OLED, have these push buttons, and the SPI for the RFM69 plus its general GPIO. Like, it was just way too much to start with when that base CircuitPython library needed to be, that was the main thing I wanted to focus on, and just only doing the OLED really allowed me to narrow down all the things that could go wrong at once. And
so eat the elephant in chunks, as they say then.
Yes, and so I actually, to prove that this I was able to, like, once I pulled the CircuitPython library over to the new image, I was able to focus on adding the stuff for the RFM69 and these 3 push buttons. And then I had a second one that I actually put on a Pi, and I think one of my other very first blogs was how to use the RFM69 on a Raspberry Pi, and doing an actual physical RF loopback between 2 Pis with 2 of these RFM69 Featherwings. And so this project was kind of cool because I was able to reference that and now replace one of the Pis with the Zynq Fairy. And this was a whole new level of troubleshooting, because now you see how important physical timing is for RF signals, and getting those two RF, like having one RFM69 waiting at the appropriate time, looking for the preamble of the RF signal to come from the RFM69 on the other one. And that was a whole other level of timing mess to, because the timing, because it's a completely different chip on the Raspberry Pi running at a different, like getting the timing between these two actually was, I spent longer on that than I did actually building the CircuitPython library for the RFM69.
That's quite impressive. You know, that's really quite cool. I like that. So have you done anything more with the RFM69, or is this where you kind of moved on to doing different things?
So I have some stuff in the works on this. I bought a so the RFM69 is just this little green chip, and so I bought a couple just RFM69s alone and some peripheral board. And my next step is I'm looking at playing with basically building my own shield for the Raspberry Pi with the RFM69 and seeing what I can do with that. And I would like to, because the timing is so sensitive and Python is not the greatest language to use for timing. Like if you dig into the CircuitPython RFM69 library, like the first comment says this is not the most efficient thing to use, because Python just is not great for that kind of tight control of timing. I would like to re-implement this control doing an HDL, like in Verilog, in HDL, where I can really get a hold of it, because I feel like that would make this a lot cleaner, and then use two Zynq berries with two RFM69s and kind of compare and see how much cleaner and how much faster I can get those two to sync with each other as far as talking over the physical RF signal.
That'll be quite an interesting. Project. So we've got one question actually that's coming from a chap Navadi. I hope I've pronounced his name right. And he's asking about MicroPython, and if you've ever tried running MicroPython on the Zynq GUI at all.
I have not. I've heard of MicroPython. I'm not super familiar with it, to be totally honest. I just converting the CircuitPython was a big enough challenge that, and I still feel like I have a lot to learn from that I don't know if I'm totally ready to switch the mindset. And in Python in general, because when I was in school, Python wasn't a thing yet, but now when college, like that's the first language most people learn now, but that just didn't exist when I was in college. And so that Python was kind of, I have a love-hate relationship with it, because I learned Verilog and how to think in clock cycles. And then I also learned just the traditional C++ object-oriented. And so to like have that mindset, and also like then I learned like the differences between programming in like object-oriented C and then switching over to like bare metal non-object-oriented C. And that's a whole, and so then I learned Python way after all that, and just some of the stuff that Python will kind of intuitively do for you in the background, I guess. Python just didn't work the way I thought it should work. And so I've always kind of had a love-hate.
Working clock cycles, does it?
And this happened to me. I wish this happened to me a longer time ago than it did, but I'd say a matter of months ago, I learned that Python like version 3 or 3.5 is very particular about tabs versus spaces.
Oh, yes.
And it was a very simple script. All I was doing was monitoring some GPIO and then toggling some other GPIO, and I could not figure out why it wouldn't compile. And then I don't even remember how I finally figured out, but I had used tabs on every line except for one. And one line I used 4 spaces instead of a tab. And that was one of those, I'm sure everybody's had these moments where you finally find something like that, and you literally are just like, I don't care what time it is. You flip the desk and you're like, it's happy hour. I need alcohol. Like, I'm done.
I'm having a beer tap installed in my office. I think it's the only way forward for things like that. But so I mean, I've not really. I guess similar to, I've not really used MicroPython. I know it was one of the candidates for the Pink project originally. before they finally settled on the full Python. But I've never tried it. Maybe we can toss a coin between us, and the one that loses has to go away and try and get MicroPython running on one of these boards. So the other question, so you've done a lot with it. You've been doing an awful lot with a Zynq, but actually you've already touched on your website, but your day-to-day job. So you're doing some quite interesting work with GoTenna. I hope you don't mind me mentioning that.
Yeah, no. GoTenna is we're a startup here in Brooklyn, New York, and we work. The product is we have self-meshing portable radios. So they're small narrowband radios, and they're intended for use for when you have, they pair with your cell phone via Bluetooth, and then they create their own mesh network between other GoTennas. So essentially this GoTenna becomes an extra antenna for your cell phone. And so if you have a group of people and say you're in the middle of the woods and like cellular is not an option or Wi-Fi is not an option, you can each have a GoTenna paired with your phone, and you create your own little network so you can still talk to each other. And it's really awesome. We have a lot of customers. It's very handy to a lot of like first responders, like emergency relief. So like the hurricane in Puerto Rico recently, we supported a lot. And then the fires in Australia, we supported a lot, because obviously when you have massive destruction like that, your cellular infrastructure is gone, but everybody still has a cell phone. So to like for firefighters and stuff, and paramedics going on rescue missions, it's really nice to just be, hey, and the GoTennas are fairly small. You can clip them to your belt or your backpack or your helmet, and now all your cell phones work to talk to each other again. So it's a really awesome place to be, and we're designing the next generation, because it's narrowband, we can currently only send text back and forth. And so where I was hired and where I come in is to create the next generation to see how we can squeeze some more bandwidth out of narrowband and start sending some larger payloads. So that's been a lot of fun, and because we have a lot of customers in the field that stay with us longer, we want this to be field updatable or updatable over the air. So to really achieve and have it also be backwards compatible with the older product, that's where a software-defined radio implementation becomes the choice versus a hard-defined. So we can hop across the different channels that we have available, and we all have to stay in like unlicensed bands, which are kind of scattered throughout the network. This is all in the US. We have to stay in unlicensed bands, and because you have to change, and it's a fairly big step between some of the licensed bands you have to change between. So like being able to reconfigure and re-optimize for whatever channels you have available and what bandwidth you have available, that's where the software-defined radio comes in and comes in handy. And being able to update it going forward, that's where the FPGA became the logical choice. So that's been a lot of fun.
I can imagine it. So I have one question on the bands, I guess, that you use. So I presume, obviously, like saying the US, you've got different bands that you can use that are unregulated. I presume as well, if you want to say use it in Australia or New Zealand or Europe, you've got different bands. So do you have to be more free? You have to design that into your system to be able to accommodate for that, or are you pretty much US centric? Or
I think, well, for right now, we're early enough on in the design point. I've really focused on just looking at, I only know like the US ones off the top of my head. However, the way I've made it configurable, I'm making it configurable from the sense of when we do maybe make like a Australian like overlay or like key for it, it's just a matter of plugging in those new numbers, but the same, like how you reconfigure that base design will be the same.
That's really quite interesting. So you're not using, because we've talked about this a lot, because we both have a love of the RF SoC, which
yes.
is so you've done quite a lot with the RF SoC.
I had some software-defined radio, like when I was at Honeywell. That was the big company I was at. When I was at Honeywell, I had some research projects that I worked on. That's where I first got contact with the RF SoC, and I had the funds to get a hold of the ZC111, which was, I think, the first and I think the most common RF SoC dev board. We were working with that just because the latency was a big thing, and getting low latency, fast speeds, and that's where the RF SoC really comes in, and being able to have those RF DAC and ADCs integrated into the chip. That's just absolutely like huge to yeah. However, the RF SoC, it's not meant, because GoTennas are battery operated and handheld. RF SoC, it's the power honestly, like one of the things I learned recently. Yeah, you'd need quite a even if looking at a Zynq versus a Zynq based chip, like the base, like not even like an MPSoC, but like a Zynq versus like an RTX or a Kintex, or just something that doesn't have a physical processor installed in it. The power consumption of having that processor physically instantiated in the chip is mind blowing. Like I ended up switching like my GoTenna base design from a Zynq to an RTX, because to just do a simple power analysis, I took the Zynq the only thing I put in the block design was the Zynq IP block, and I generated a bit stream and looked at the power analysis. Just having the Zynq instantiated and turning on the ARM core draws 1.3 watts. Whereas if you switch to an RTX and just put nothing in but the microblaze, and it's bare bones, like it's only 0.3 watts. And I was just absolutely blown away at the power consumption difference of just that physical processor. So that's one thing I've learned. If power is a big thing for you, stick to soft processors.
I think it's quite interesting. I mean, I think you can do a little bit of tweaking with a Zynq, but it's a lot more painful to.
It is. I was looking into everything as like, oh, I only need the one ARM core, so let me shut off the second one, and that eliminated a good chunk of it, but it still didn't get it as like I was just like, why go through all that pain when I can just switch to a microblaze and no physical processor? And that cuts out a ton of power, like more than. And because getting to the point where you're trying to shut off one core of the ARM and then like shut off the ARM core off of it, it got so intricate, and I spent more time working on that than the actual radio design part of it, and I was like, this isn't worth it.
No, it's an interesting thing. Sometimes as an engineer, you have to kind of go down this route and go, it's not quite right, is it? I'll just go back and I'll not be so emotionally invested in it. Let's just go back and actually take a look at it.
I see a question on here. I just wanted to, I just caught my, so there's a question that, can the RF front end be configured for all the bands? Question. So that is something interesting. That's where the RF front end is where you get constrained, and what you end up having to do is just design your front end or pick a transceiver chip that covers a wide enough bandwidth for you. And at some point you are going to be cut off, and like there are limitations, but you can be strategic in how you choose those transceiver chips and how you design the front end. And that's a whole other talk that I don't know. I'm not quite as I tend to just pick transceiver chips, and then I also have another RF engineer on my team that he's absolutely brilliant and has helped a lot with that. Because I just, instead of doing like discrete components, like I'll just look through some data sheets of RF chips and just go with that. But if that's something you're kind of want to get more familiar with, there's the Pluto. It's a Zynq-based SDR. That's a good one that if anybody's really interested in that, you can kind of, if you want to focus more on getting to know the RF, I would recommend that, because there's a lot of good resources from Analog Devices on it.
Did you ever get one, a Pluto board? I never got one. I tried to buy one, and for some reason it never happened. But, yeah.
I have one here for development purposes. I haven't used it in a while just because I've been pretty focused on internal designs. Yeah. And the Pluto I really use for proving in like physical RF type design.
Yeah, I think somebody's just popped a comment in there saying actually it's a nice little SDR. So I think I might. I think the reason they wouldn't sell me one is I wasn't VAT registered. So now I am. So I'll go back and buy one and see what trouble I can get up to.
Yeah, there's a lot of weird export control laws around radio stuff here in the US. So it can get weird.
Yeah, I think they wanted to know they were selling it to a proper company, not some bloke sat in his spare bedroom office type thing. Which is, but it sounds like, it sounds obviously we've done a lot of work in the RF side of things, in the RF world. you've been doing some really, I saw a really good project from yours the other day about on the Eclipse Z7. So you've been working with Zmods as well. So I'm really, having just made this little board that plugs well, I hope plugs Zmods onto it. What do you think to the Zmods? Are you enjoying working with them? Is it a good standard to be using? Or?
I really like them. I'm still getting to know them. I haven't on it, like I'd heard of the SysG, but this interface that the Zmods are based off, but I hadn't worked with them. But the Eclipse is very appealing to me, especially right now, because it's the best option for there not being an affordable RF sock available. I've been hounding some contacts at Xilinx. I'm like, please make an RF SoC version of the Ultra, because that was the point of the Ultra 96, was to make an MPSoC version like that was affordable to the hobbyist community. And I'm just like, you've got to make that. And so the Zmods with the ADC and DAC, while it's nowhere near the speeds of the RF ADC and DAC in the RF SoC, it's the closest thing to, like, as far as it's got the high speed interface, because like when you have these high speed signals, like the PCB layout is everything and the connectors are everything. And PCB layout is something I keep telling myself I'm going to take the time to learn, but I just haven't had the time. And so the Eclipse and the Zmod, having that all where I can just plug things in and have that all taken care of for me is a big thing and was very appealing to me, and why I ended up getting one. And so being able to take that and now put it on other boards, like that, the idea of that's very exciting to me. So that's one of the things I've been working with. That first Eclipse project, which I meant to make this all one project, but that first Eclipse project of like just getting started and walking through importing all of the Zmod custom IP and getting it all hooked up, that ended up becoming such a monstrous, like, detailed project that I was like, there's so much here to take in, that the SDR specific project I wanted to do with it, I was like, I feel like anybody that has gotten this far in the tutorial is going to be completely saturated, and I need to just make this a separate thing. And I've kind of had to pull apart some of the design too, because I want to put the Xilinx, the DDS compiler IP to output a sine wave to the DAC.
As well, because you've done you did a really great tutorial. Was it on the Ultra 96?
Yeah, it was the Ultra 96 with a DDS compiler instantiated in the Verilog, not the block design, but the Verilog, and controlling that from the Verilog to get the timing. It's easier to hit the timing on it in Verilog when you have that granular control, because that's going to be one of the things I'll go over in the new. Like I'm posting another tutorial on the DDS compiler on the Zynq, where I've got it instantiated in the block design and I'm controlling it from a bare metal C application. And the reason I felt like that project was ideal is the way you have to think about the timing for the sine wave and being able to get the sine wave out in exact periods and it look right. It's a whole different mindset and different things you have to worry about when you're controlling it from embedded C versus the Verilog. So I thought that contrast would be nice to have those two different tutorials. But
that'd be quite nice. So I really enjoyed reading that tutorial. I thought it was really quite good.
Oh, thank you.
And I used to do some stuff on Astrium with like up converters and down converters and stuff. And actually, we were trying to make the RF sock, but it was board size level, so the RF sock just beats it all down to death. But it's one of those things I really enjoyed reading that. So somebody's just asked a question actually in the Q&A channel about saying that, and I'll read this out, saying a few years ago he designed reconfigurable fault-tolerant frame synchronization that can detect spectrum inversion and high-level data link control protocols using VHDL as a freelancer for an SDR project. But I have zero knowledge when it comes to RF. How hard would it be for an embedded FPGA engineer to get into SDR development?
Well, I feel like the question is more like, it's not, because software-defined radio is, you're asking more of like, how do I get into the RF world? Because understanding just how an RF signal is formed and how to handle, like how to manipulate, like go from your baseband signal to your intermediate frequency to your RF, that's honestly a totally different world, and you have to understand it before you can translate it to embedded. So you kind of have to take from the, it's not really like, oh, I'm learning this from an embedded perspective. You really have to just go and be like, I need to learn the RF world. And I think like all about circuits and even like Analog Devices websites, they have a lot of those base kind of like theory. You'll have to go back and start with some of the painful theory of it. And then I think there's GNU Radio. If you you can start putting building blocks together and doing loopbacks within, and you can use like the audio card in your computer for that. That's really where you're going to have to start. Just really understand the RF signal and how you're manipulating it and why you're manipulating it the way you are.
So you mentioned an interesting point there, because GNU Radio. So do you use GNU Radio much? Because I hear a lot about it, but I've never actually tried it or experimented with it. Is it worthwhile taking a look at or getting to grips with? Or?
I think it's a great tool to learn to like put some theory to practicality and for development. I've only ever used it from a development standpoint to like maybe prove an idea, but I've never actually like, oh, this is the thing that I'm deploying.
Yeah.
And I think with a lot of other, especially with the RF SoC, like sometimes it is a trade-off, like depending on what you install GNU Radio on. Sometimes you spend more time figuring out how to install GNU Radio than actually learning it. So I would recommend just installing it on your normal computer and looking up some base tutorials and like doing loopbacks on it and just using it as a tool to learn on your computer rather than trying to like put it on something. But that's just been with my personal experience. Because I see a comment, works with a bunch of SDRs.
Yeah,
I mean, like when you're using it, yeah. But sorry. I started reading and stopped talking.
Started reading and people putting the other questions, and it's moves up the list, so it scrolls through. It's an interesting one. I mean, a few people mentioned about getting an amateur radio license, and that might be a way from the start as well, and start learning that way the RF signals and the RF propensity.
Well, getting your ham radio, I feel like the only thing with a ham radio license is it's kind of like you get a driver's license to know how to drive a car, but that doesn't necessarily tell you how to build a car, how to fix a car. So
really good. That's a really good analogy. The next time somebody says to me, I just got my ham license, I'm going to be like, okay.
It's a great thing to have, and it gives you the ability to use a ham radio to work on one to figure out, like, because obviously, like, and you only need a ham radio license to transmit over the air. You can receive, well, this is in the US. In the US, you can receive all you want without a license. It's only when you want to go to transmit a signal. And honestly, like in my the RFM69 project, that was the whole reason that instead of using antennas on the RFM69, that's why I had a physical cable. Mm-hmm. Is I haven't had the time to go get a license, and I also figured a lot of my readers wouldn't have licenses, so that's why I thought the safest thing to just avoid the whole issue is just physically connect them with a coax cable.
Yeah, I'm the same. Actually, I always connect things directly with physical cable. Many years ago, I was working on an IFF system, identification for endo-firm, and we actually had the system doing the radar, doing the transmission, and it was doing the encrypted waveforms and everything. But we'd not really told anybody about this. And then the next thing we knew, we actually had a US Air Force F-15 flying over the airfield we were testing at, because it was being interrogated. And it wasn't replying because it had not got the test codes, not got the reply because we got test codes loaded in it. And the pilot was just coming and saying, somebody's interrogating you and you're not replying. What's going on? And then not long after that, the police turned up and said, what's going on here? We're like, well, we are actually working for a defense company doing all this. But yeah, you can get into trouble quite quickly with broadcasting things inadvertently.
Well, and one thing I see a comment says there are also bands you can use without a license, and there are still stipulations on that, like the amount of power you can transmit on and the transmit lengths. So it's not that those bands are free game. There's still power, at least in the US. I do need to disclaimer everything. All my knowledge is fully US. there are still stipulations on those free bands. They're not totally free.
Yeah, I think 2.4 gigs is the
That's
Wi-Fi. Is the Wi-Fi.
Yeah.
So your neighbours will really love you if you're doing a little experiment, and they can't binge watch, particularly in the quarantine. It's got all the hallmarks of a great TV, of a great news story about an axe murder. But you've been doing that.
Yeah, no internet in quarantine is rough, because I actually my lease came due, and I moved to a new apartment, and the internet company, they were all booked up, and so I spent the first week and a half in my new apartment with no internet, and wow, that was painful.
What did the days seem to just like go on and on and on and on?
Because there's like a common area in my apartment building that they have Wi-Fi there. That's like, it's an open network and it's a fairly weak signal. So I actually spent a bunch of time trying to figure out how I could like repeat that signal or like hardwire it into my apartment. So I got fairly distracted with that.
I'd have been sat down there with a sleeping bag in the open air going, well, this is where I'm staying for the next week.
I ended up giving up that endeavor when I went to the common area, and the internet was so slow it was just unusable. And I'm like, well, I guess it's free internet. You get what you pay for. And I kind of gave up after that. But then I just ended up paying for a hotspot for my phone. So I was like, I have to have something.
Yeah, I've actually phones are quite good as hotspots for the internet. So
It's just with my apartment building, I have to stand in one specific little area, because like the way the concrete building is, like I'm in a perfect like little dead zone. So it was like I just had to, like, when I did use it, it was like in this one little huddle next to the window.
It's a good example of RF attenuation then. It's through the
multipath, like
that's the word I was looking for, multipath. Yeah. So I mean we're getting towards the end of our random chat. It's been a very sensible chat here. You know, we've talked about really grown up intelligent things, and then camping and free Wi-Fi. I mean, so what are you working on at the moment with your projects and blogs? You mentioned a few things about the CircuitPy and the Eclipse. You mentioned one thing I meant to ask you about this earlier on. Your subway monitor on the Ultra 96.
Oh yeah, when coronavirus first became a thing here in New York, before it just sounded, at first it was just kind of a buzzword on the news, and then it like slowly became more, or well, not slowly, like as it became more serious. But this was like right before lockdown. I had wanted to start avoiding the subway as much as possible, and like because it's a necessary evil here in New York, I just wanted to limit the amount of time I had to spend on the platform. And I found that in the sub, for those not familiar with the New York subway, when you're down in the subway, there's these digital boards that have a countdown for the next train coming. And after some research, I found that the MTA, the Metropolitan Transport Authority, they're live feeds that they make the URLs available on their website, and you can sign up with them as a developer and get a key for these licenses for personal use. You can't make your own app and sell it with them. But for personal use and just using it yourself, I found you could sign up and get them. So I decided the Ultra 96, doing web pages and like Flash servers, that was something I didn't know anything about but wanted to kind of figure out. So that's why doing the custom web pages on the Ultra 96 was appealing, because like, oh, this is a way to teach myself this. And I thought, oh, it'd be really nice to, like, instead of having to, like, there's nothing more infuriating to a New Yorker than getting into the subway, getting to the platform right as the train you need is pulling away. And I was like, oh, it'd be kind of nice for like to wake up and just from my phone check a web page to see like the next series of trains. So I know exactly how much I can time when I walk down there, so I can just get straight on the train. I spend the least amount of time possible. So I created a web app that queries those live feeds and then shows me the list of the upcoming trains for the rest of the day for a certain station. And that became a big thing. And I promptly realized how much I would like to use that when I'm not at home on my Wi-Fi, which is ultimately what led to the port forwarding tutorial on the Ultra 96. Yeah. And then I have a couple friends in the building here and they were like, oh my God, we want that so bad. And that was the other thing. So
So you're now charging a subscription service, yeah?
I can't. Unfortunately, I can't. I wish I could. Like, if I could charge on something, that would violate the license.
Yeah, I remember you saying
but,
that. I was teasing.
Yeah. But I do. There's some stuff I have hard coded in that particular web app that I would like to make configurable. Like right now, like there's only like Manhattan bound trains. I want to make it configurable between Manhattan bound and Brooklyn bound trains, and then just make it. I only have 3 different train lines in it right now, so I want to add the rest of them and just kind of evolve it from there. That
sounds really quite cool. I mean, how did you find creating the Ultra 96 webpage? I found it interesting working with the Flask and everything on there. Did you find anything?
Well, the first thing I discovered, like, just every time I get a new dev board, even though there's typically like pre-canned images for like Petalinux and Vivado, I really enjoy making my own project. Like, I want to start from scratch and just start with nothing more than the board presets. And I really want to learn, because like if I want to go back and add my own stuff to it, I feel like it's a lot easier to go back and add stuff to the block design when I built the original block design. And when I was building the Petalinux image for the Ultra 96, I was having a hell of a time getting it to connect to my Wi-Fi. And every time I would go to connect to my Wi-Fi, it would crash.
Mm-hmm.
And it was just, I spent more time than I'd like to admit on it. And then I finally discovered, because I was keying in my the SSID and my password into the WPA supplicant file, and I was having to do special characters because I had a space in my Wi-Fi name.
Yep. Not the, yeah.
Which, for reasons I have now discovered, are taboo. And so finally, I was at the end of my rope. I was like, I don't know what else to do. And because like I was in a Stack Overflow thread where somebody was very passionate about spaces and Wi-Fi names and just very angry about it. And I'm like, well, there's probably a reason this person is very angry about it. So I ended up, I dug into my router, changed my router, and I changed my Wi-Fi names to get rid of the space. And lo and behold, that was the problem the whole time. I'd spent all this time troubleshooting the kernel and all this stuff, thinking it was like, that was just the space in my Wi-Fi name.
So somebody's just commented, I'd say, yeah, there's just commented that Vivado, even spaces and even Vivado projects are bad. And I do, I'm sure you'll try, they really do break it.
Yeah, I've got that became, and that's another reason I shouldn't have spent as long on this, is because I had discovered the spaces in Vivado project file names being bad. Like I always use underscores or just squish everything in together. Like, and so that's why I said it should not have taken me as long to figure this out as I did.
But it happens to me, or it happens to everybody. I think you sit there and you get one particular thing, you're like, why is this? And then you suddenly work it out and you're like, yep, of course it is. I should really send that engineering degree back, shouldn't I?
Well, it's like the easy thing. You just think it's like when you're doing, like when you're debugging a kernel and going through the backtrace, like that's such a, like you get into the complex and you're just like, there's no way it's this simple. And you're so
it has to be
tunnel visioned on finding the complex answer that you like, it's really easy to miss those like, duh, the switch isn't even on type problems.
That's the great thing about engineering. You know, some days you get to feel like a legend as you create things, and we talked about earlier on. You jump around shouting yay, and then the other things you're like, I really should have known better than that. I really should have turned it on first.
But going back to the Ultra 96, because I'd spent so much time messing around with the Wi-Fi, that's how I was digging around in the home page, like the web page for that, and that's how I found like, oh, make your own web page, and that's ultimately where I discovered all that and started developing.
I thought it was quite a unique thing actually on the Ultra 96. I quite liked it. It's a good way to do it. I must. But then I kind of went off. I discovered the pink image for the Ultra 96, and I've been using the pink image quite a lot more than I have the original.
Well, the original, I was thinking of it for more like SDR applications, because I did a web page beforehand that was an RF spectrogram, and the intent there was to make that, because right now I had like a Python where I calculated the RF spectrogram, and I ultimately wanted like my shield idea to have an RFM69 shield. I ultimately wanted to like have some sort of RF front end that fed the spectrogram web page versus just me calculating it in Python. So that's initially where all that starts. So that's another reason I'm kind of excited to like use your breakout board and get the ADC Zmod on it and see kind of how I can start feeding it from there.
We have to make sure that I've done the board right first and that it actually works. I'm sure. I'm really confident your elements will work. I'm not so confident I got everything right when I was designing the board. But I guess
it might take a while to get my part to work. I'll eventually get it to work though.
Yeah. Well, I would say once I get one in my hand, I think I've got it ADC and DAC. So actually, one of the things I wanted to test for the Zmod was actually just creating a simple sine wave count coming out of the ADC on it, just to make sure I'd not missed any bits or switched any lines or anything like that in it. So hopefully by the time I get it to you, we should be touched with fairly confident
that's kind of a similar point I'm at with my like software defined radio, the development for like particularly GoTenna. It's just like you can test bench all you want your designs, and especially because I'm interfacing with an external like transceiver chip, and like I've coded all this stuff and like it passes all my test benches. However, I'm a little bit I haven't gotten to the point where like I'm physically interfacing with it. It's like, yeah, it passes my test benches, but if I have like a fundamental logic misunderstanding with how the transceiver interface works, my test benches aren't going to catch that because I coded my test benches with the same fundamental misunderstanding. So there's that nerve-wracking like testing physical signals with your FPGA designs. I feel like I sink the most time there because it's just like, okay, now you've got this thing from the outside world that it's like it never quite behaves exactly like you thought it would.
It never does, but at least having a little bit of a test bench allows you to find somewhere so that you can kind of go back and twiddle and fix it to say, well, it's behaving like this, so I can change my test bench to behave like this, and then I can kind of fix it. I guess we're pretty much out of. In fact, we've run over. I'm going to rename this because everyone I do runs over. I'm going to rename this the embedded hour and a bit. Because it always true to
the embedded hour and some change.
Yeah, true to being an engineer, we always run over slightly. We never under deliver. We're never on below schedule. We always over schedule. So we will, unless there's anything you want to. Any quick questions anybody's got that they'd like to ask Whitney? We'll begin to wrap up. The one thing I did want to say is obviously thank you very much, Whitney, for coming and talking to us this week. I think it's been really good fun. It's been I've really enjoyed it. I'm sure everybody else has too.
Well, thank you for having me. I really enjoyed being on.
No. Thank you. It's been really good fun. And like I say, I recommend everybody go check out your projects and blogs because they really are quite exceptional. Oh, we have a couple of things flashing away in the chat window. Okay, so somebody was just saying thank you very much for that. What I will say is the next one in about a month's time. So we have my friend Tamidi who's going to come on. He's formed a company called CircuitMind, and he's actually really quite interesting. He's using AI to design circuits. So he's using, you can define what you want the circuit to do at a very high level, and then his tool will go away using artificial intelligence and go away and create the circuits. We'll select components and go away and create a system. And it does seem to be working. And there's a few boards that have actually made it out into the real world. So I think it'll be quite interesting to have him along and have a chat about how he's done it and what he's doing and what their plans are. So
yeah, that sounds really awesome.
Yeah, I think it's gonna. I sat through a talk of his about 2 months ago, and I was like, I really need to get this guy to come and talk to us. And very kindly, he said yes. So it should be quite awesome. If you've got any questions or queries, or if you've got any suggestions for any Ultra 96 breakout boards projects, or you want to come and talk, then just drop me an email to my email address, and we'll take it from there. But if not, thank you very much, everybody. I'll pop the recording over the next few days on YouTube. Yeah, I know you've got a long drive tomorrow, Whitney, so have a safe drive home.
Well, thank you.
We'll talk to it. So somebody just asked, actually, the breakout boards are available to buy. They're not yet, but I've got a small number of them. So if you've got a cool project or you've got something in mind for it, just drop me an email and I'll pop one in the post here. And then then you can have them and take it and see what you can do with it. Perfect. Right. I will leave you all in peace. Thank you very much. Have a great weekend, and I'll see you later. Bye bye.